Hey, good day, everybody. We've got a Precision International Beetle 1000S distance measuring equipment used in survey. This is from the late 70s, I think about 1977. This is almost $4,000 in it's 1977. It was pretty precision. It uses light, and it does it by the phase difference between the outgoing and the reflected image beam, and is really kind of cool. And for being as old as it is, it's pretty good. The digits are kind of fading out on the right hand side. LCD display gets better as it warms up, but I thought I'd go through and just show you quickly how this operates. You have the ability to flip between feet and meters and feet. The feet indication doesn't go away for some reason. The S means it could do slope calculations for you. This would be mounted on a theodolite, and you'd read the angle that the theodolite was pointing at your reflector. You'd input that with the thumb wheels, and you would set whether you wanted the slant range, which is the actual point-to-point distance without any calculations, the horizontal component based on that angle, or the vertical elevation component based on that angle. So it could do all the math for you. I just keep that there. Offset, you could set how much of a millimeter offset your prism was, and of course the angle that you would set, and then your parts per million correction for atmospheric pressure and temperature. And that is actually the current one for 75 degrees and 30.15 inches of mercury. Set it on 39. And what you would do is you'd let it warm up for a minute or so, and you put it on just on single operation, and this is the button to trigger a reading, and you'd put it in calibration, and you just and this is the calibration sensitivity on this side. You can see as I move it in here. So you put it right at the point of that arrowhead, and you fire off a calibration. And you're trying to get as close to 2,000 as you can. The digits are missing on that last one. I'm not sure. Yesterday I was looking at it, we were at 0.89 in there. That may be what that is, which is what we're 0.11 meters off, which is just a couple of inches. This should be within 5 millimeters, so it would need calibration. I don't know who does that, but I'm not using it for surveying. I'm just using it because I love math, and I do recreational surveying if that's a thing. Anyway, so once you've got this stabilized, and it's been warmed up for about 5 minutes now, we'll do one more, see what happens. Yeah, there it is, 0.89. And so we're going to say that's going to be our calibration. You'd flick it off calibration to operation. I do in feet because I have set out there a driveway reflector, which actually works out to about 100 feet or so. I haven't tested further than 100 feet. I also have a actual survey retro reflector. This is good for, I think, 1.5 kilometers or something like that, or maybe 1 kilometer. That's what the 1000 stands for. Anyway, so but this works, and the way you would aim it on a theodolite, of course, you'd have it trammed in so that everything lies whatever you're looking at. This was aimed at, but even this just on a standalone tripod is not too hard. What I do is I eyeball it vertically on the top of the reflector. And I'm going to do that by eye real quick. And we are there. And then I just go into the corner here until I can see the reflector. It's not going to focus on both, so I'm going to do it by eye real quick. And you'll hear it start. Oh, I flicked this to audio first of all and set the sensitivity to max. That's something you want to do while you're hunting for the target. So I'm going to go, and I am going to slew this. Oh, and there you hear the buzz. And then, now you've got it audio, you can turn the audio off. And now that we're on operation, this is the sensitivity of the read head, not the calibrate head. And we're going to align, I'm going to go left and right to max out the signal here. That looks like max there. So I'm now going to bring the sensitivity down to put it roughly into the point. And then I'm going to check the vertical here and see that I could do a little more there. So I'm going to bring this down back to the point. And we want it to be right at the point in the same spot we had the calibration, because during a reading, it flips between the calibration circuit and the read circuit outside and compares the two. So we're going to fire off a single reading by pressing the button. And considering I placed that kind of by eye at 50 feet with a tape, and it's reading 49.88 feet, and which is 0.12 feet off, which is about 1 inch, I think a little over 1 inch of error. And that's just not using a plumb bob. That's just kind of eyeballing a mark. I'd say this can get you within an inch of actual distance. So that's how you operate a Beetle 1000S.